Hello, everyone, and welcome to our meetup about design patterns when using MongoDB, but not only MongoDB. It might be relevant for other NoSQL document-oriented databases.
Progress.
Okay, first let's start with explaining the term design pattern. I believe most of you are familiar with this term, so I will try to make it short. What a design pattern is. So a design pattern in software development is a reusable solution for programming problem we encounter with when dealing with common programming problem. Then with time, best practices emerge and a design pattern is shaped. And there are, of course, those classic design patterns we all know, most of us know, that were created by the Gang of Four in 1995, and they refer object-oriented programming. And for each design pattern, there is a name and there is a detailed description of the intent, which is the problem for which the design pattern was created, and code sample. And the code samples in that book are in C++, and there is also a simple UML diagram. You can find design patterns not only in object-oriented programming. You can find design patterns in the server side. On the server side, the server-side domain is a huge domain. You can develop the server side in Java or in other programming languages. And yet, there are common problems you will encounter with. So this is another domain of design patterns. You can talk about design patterns in functional programming. You can talk about design patterns in the web browser, specifically for the web browser. In this meetup, we're going to talk about design patterns that are relevant for using document-oriented database, such as MongoDB. And those design patterns I'm going to cover are described with great examples on MongoDB website. You can find detailed description I will show you for each design pattern. We're not going to cover all the MongoDB design patterns we can find, just a few of them, but I created a link, this link. If you click this link, you will get to a web page on the MongoDB website where you can find a detailed post with detailed explanation for each and every design pattern that those consultants working in MongoDB took the decision to include in this detailed post. Now, we're dealing with design patterns based on experience people in MongoDB have gathered during their work with other companies. And as I said before, even though the title of this meetup is Design Patterns when using the MongoDB database, I believe that most of the design patterns listed in this post are relevant for other document-oriented NoSQL databases, or most of them. So I believe that we will cover 3 to 4 design patterns, explain those design patterns I chose, and then we shall have a small session of Q&A. And if any of you is working in a company interested in detailed training about this topic or about other related topics, then just check out the website, lifemichael.com. There, you can find there detailed information about professional seminars I've already created, and courses, and I have lots of courses on Udemy, and I have courses on my platform, and of course tailored training for companies according to their needs. You will find all information in this website. So let's start with computed. As I said before, for each pattern, you will find a detailed description on MongoDB website. So computed, what is it about? Well, computed is a design pattern that was created for those cases in which we find ourselves having a calculation that is executed again and again, and we get the same result in each execution. And then we say, okay, instead of executing that calculation again and again, let's execute it only once and keep the result, so we can use that result whenever there is a need for that specific calculation. Imagine, for instance, a platform that provides reports to its users. Imagine Google Analytics, for instance. Google Analytics tracks the visitors in your website or the users in your mobile application, and you can get detailed report. Now, when asking for a report for a specific month that already passed, there is no need to recalculate that report again and again whenever it is required. We can have our server side have it including code that will store the calculation that was executed for the first time, and store the results, store the report, just so that if there is another request for that specific report for that specific month, it would be possible to fetch the data from the collection that holds a document, detailed document, which is actually the report. So instead of calculating again the report whenever there is a need for a detailed report from Google Analytics for a specific month that already passed, we shall use the report that was already created in the first time. And by doing so, we actually improve the performance, because the query, starting with the second request for the report, will be faster, and it is just about returning back the report, the detailed report. So this design pattern is called computed. Here's a sample screenshot from the MongoDB website. Just imagine that we have detailed data about how many viewers, how many people watched a specific movie in specific cities, and we need the total number of viewers. So the data we have on the database is multiple documents. Each document refers a specific city, and then calculating the total, we can store the result in another collection. So next time when there is a need in that total, we won't need to go over all documents and calculate it again, because we already have it. So the idea is calculating the result and store it for future use. Pay attention, it's not always a good choice, a good decision to use the computer design pattern. You need to pay attention to cases such as I skipped the slide over here. We pay attention to cases in which the overuse of this pattern eventually damage the overall performance. And I mean those cases in which the reports are not required more than once, and just saving those reports for the future when actually in most cases they are not required in the future is actually eventually brings more damage than good. So it isn't always a good pattern to deploy, but in many cases it is. And in most cases, the performance improves. The queries become simpler and faster. Okay, so this was the first pattern. Let's move forward to the next pattern I chose to cover in this meeting. Approximation. The approximation pattern refers those cases in which the accuracy of the data is not a must. We can avoid being accurate and have the representation of the data not accurate. And there are cases in which we can avoid overcomputation, avoid computation on the server side, and manage and remain with less accurate data displayed on the screen. I will explain. You are probably familiar with the average reviews each product on Amazon or AliExpress get, the number of stars. So we have 5 stars, or 4 stars, or 4.5, or 3.5. Well, there is no need in calculating the exact average of all reviews whenever a review is needed, whenever there is a need to show the number of stars for a specific product. We can avoid recalculate whenever we can avoid the recalculation whenever there is a need to show the number of stars a specific product has. We can be less accurate, and by doing so, save. By doing so, have our server side more efficient. Less operations will take place. So showing data to the user which is not accurate, there are cases in which it is fine, it is okay, no damage happens, but we should be very, very careful, because in some cases, having approximated data, meaning not having the exact data, might create some damage. So it depends on the case. The case of showing the number of stars a specific product on Amazon has is a classic case for using approximation. We won't do the calculation again and again whenever we need to show the number of stars. We should have it calculated, let's say, every week, and we should have it stored on a separated collection. So we can say that it is kind of implementing approximations together with computer, and this is fine. But showing, for instance, the temperature in a specific location, which happens to be a ski resort, and not be accurate about that temperature, this is a case in which approximation is not implementing approximation in such case is not a good decision, because the temperature, if it is 0 or 0.5, it has implications on those people that visit the ski resort. So because they want snow, they don't want rain. But as I said, in those cases that we can show the data less accurate data, and the user experience doesn't is not damaged, then approximation fits. Okay, let's move forward to the third pattern I chose to cover, extended reference. Well, in many cases, we have separated collections. We have a collection for holding data about invoices on the one hand, and we also have, on the other hand, a collection with documents that each and every one of them describe a specific customer. Well, one way of working with these two collections would be having a join query. Whenever we need to show the data of a specific invoice, we should query the two collections, the invoice collection and the customers collection. And then we shall take the data, put it together, and show the invoice and allow the user to print the invoice, for instance. This is the common case in which most developers choose to use a join query and keep the data in two separated collections. Now, if we take from the customer collection just the data that is required for producing an invoice or for producing an order, data that is kept separately in the invoices or the orders collection, we improve the overall performance because then we don't need a join query in order to produce an invoice document or order document. We just need to query the invoices or the orders collection and get that document, take out the data from that document we got and compile and create the invoice document. And by doing so, we indeed have duplicity of data. We have some data both in the customer collection and in the orders collection or invoices collection. However, the bottom line, the improvement we get in the performance of our system might justify this duplicity, which is just in order to avoid the join query, which is relatively an expensive query. Okay. Now, a side effect you should be care about is the duplication of the data. When having the same data in two separated collections, and then over time that data change, it means that the new up-to-date data won't be necessarily reflected in our system. For example, just imagine we have the orders, or let's say the invoices collection, and we have the customers collection, and then at some point, the address of a specific customer change, and then we need to produce an invoice for that customer, and the address of that customer is kept both in the customers collection and in the invoices collection. In that case, the invoice we produce won't show the accurate address. It will show the old address. So if we can live with that, fine. If not, if it is a problem, then going with the extended reference design pattern, implementing the extended reference design pattern might be a problem. Okay, then now let's move forward to the last pattern I chose to cover, the bucket pattern. And the bucket pattern refers to those cases in which we have stream of data coming from sensors, stream of data coming from users of an application such as Waze. You know, the Waze application, when you install it on your mobile telephone, whenever you go, it sends data to the server side so that the server side knows the exact speed of every user. The server side know, according to the data it receives, which path to recommend a specific user that want to get from point X to point Y. Now, that data that comes from the users of Waze, we're dealing with huge data. Now, just imagine that whenever data comes from a specific user of Waze, it is saved to the database. If we do it that way, we will find ourselves handling collections with huge number of documents. We will find ourselves dealing with queries that deal with a huge number of documents that our code needs to query, get from the database and go over and use. We can improve the performance by taking a bunch of documents and put them together into one big document. Just imagine that instead of separated documents, that each one of them show the exact temperature from a specific sensor. Instead of having multiple documents that show the temperature changes during, let's say, a specific hour or a specific day, we can just take all of those documents, all of those small documents, put them together and have a big, giant document. Doing so, we will find ourselves with collections that hold a smaller number of documents. Doing so, the performance improves. Doing so, when we need to query the data, it would be simpler because instead of getting tens or hundreds of small documents, we should get one big document or few big documents, and then it would be simpler to fetch the required data and complete the calculation we want to complete. Okay, then, so it was faster than expected. This was the introduction for 4 simple design patterns. As I told you before, you can find detailed explanation for each and every pattern on the MongoDB website. And as I already mentioned, most of them probably relevant for other document-oriented NoSQL databases. So now that we reached the end of the slides, a question you want to ask, please don't hesitate. I will upload the slides to SlideShare and send you the link, and I will take the video and upload it to YouTube so you can get it on YouTube. So if you don't have any questions. Okay, then, so thank you for joining the meetup and have a great day.
Thanks.
Thanks.
Bye-bye.
Bye-bye.
Bye.